So we know that a system of equations, you're finding the point or points that make both equations true. With inequalities, we're finding all the points that make both inequalities true. And because they're inequalities, there will be more than just one. It's more points than we can list, so we use shading to show the points that make it true. So we have to start by graphing our functions. Big things to remember: if it has an equal to, then we do a solid line. If it does not, then what do we do for our line? A dotted or a dashed line. Okay. So if I take a look at this one, both of these are lines. If we want to easily be able to graph these lines, what should we do? Put them in y equals mx plus b form. So this one we can subtract our x. So that gives us y is less than or equal to 2 minus x. Or you could write that as negative x plus 2 if you prefer. So we can see it's just a line, y-intercept of 2, slope of negative 1, so down 1 over 1. And that would be a solid line because we have the equal to. Okay, but then with the inequality, what do we have to do? We have to shade. So we need to figure out where to shade here. There's a couple options for that. One of them you probably did in Algebra 2 was just picking test points. So we pick a point not on the line. 0, 0 was a favorite unless it was on your line. And if you put 0, 0 in there, you get 0 is less than or equal to 2. Is that true or false? True. So 0, 0 works. 0, 0 is below the line, so that means we're shading below. Now this is not our final answer yet, so just lightly shade that part in. The other option, I always tell my students, if you're comfortable with this, you can. If you look, the original inequality was y is less than, so the y's are below the line. And so you could think we shaded below those y's. All right, next one, if I solve for y, we have to subtract the 2x, so y is greater than or equal to negative 2x plus 4. So we start at 4, slope of negative 2, so down to over 1. Solid or dashed?
Solid.
Solid again. And then we have to figure out where to shade. So you could say greater than would be above our line, which is to the right. Or if you didn't like that method, you could try putting in 0, 0. You get 0 is greater than 4, which is false, so you can't shade 0, 0. You shade the other side. So our answer is the overlap. The overlap here is this region in between the 2 lines. So it needs to be clear from your graphs what your final answer is, so darken that part in. Some people like to go back and erase the other shading. Whatever works for you, as long as I can clearly see that this is your solution. So this should be darker, or some people color it in pen, whatever you guys like. You guys think you can try one? So here is your problem. So on the first one, if you solve for y, we have negative 2y is less than negative x plus 6. If you divide by a negative, what happens to the inequality? So it becomes a positive 1/2 x minus 3. So start at negative 3, slope of 1 over 2. Will this be a solid or a dashed line? because there is no equal to. Okay, are we shading above or below?
Below, above.
Greater than is above, or if you put in 0, 0, you get 0 is greater than negative 3, which is true. So we're shading this part. All right, second one.
Wait. Did you flip this? Oh, no, you did. I can't.
So if we subtract over the 2x, then divide by negative 4, which flips our inequality. So we get y is less than 1/2 x. So this one is a y-intercept of 0, slope of 1/2, so up 1 over 2. Good morning. And solid or dashed? Dashed. Which side are we shading? Less than would be below. If you didn't know that, you have to pick a test point. 0, 0 won't work this time because it's on the line, so you would have to pick any other point. So maybe 1, 1. So if you did that, you get 1 is less than 1/2, and that is not true. So 1, 1.
It would be on the other side.
1, 1 did not work, so it's on the other side. So we're shading below. So our overlap is in between. We got parallel lines here, everything in between. Is that one okay? Let's throw in a nonlinear one. So x squared plus y squared is greater than 9. If we don't know what the graph looks like, what can we do? Teacher. Okay. So let's start with some easy ones. If you put in a 0 for x, pretend it's an equal to for a second. If x is 0, you get y squared equals 9. So what's y? 3 or negative 3. So we get 0, 3, and 0, negative 3 are points. If y is 0, then x squared equals 9. So x could be So we have 4 points right here. 0, 3, 0, negative 3, 3, 0, negative 3, 0. Can you tell what this is going to be?
Circle.
It's a circle. Should that be a solid or dashed circle?
Dash.
And why do I know that?
Because it's not equal to.
Because there's no equal to. Okay. So hopefully yours looks a little more circle-ish, less footballish. Mine is definitely not great.
I was looking fine at the top.
Yeah, the top was good. The bottom things just kind of fell apart.
The top looks like it was like computer drawn.
Yeah, see, sometimes I have a little talent, and then I keep going, and it's just all downhill from there.
You just like it's your head.
Okay, if I want to figure out my shading, since it's not a line, it's harder just to look at and know, but if you put in 0, 0, is 0 greater than 9? No, so that's false. So 0, 0 doesn't work, so it's like everything outside. So we're shading outside this circle. Alright. This one, if we subtract the x, we get negative x plus 3, so that's a line. Y-intercept 3, slope negative 1. Solid or dashed? Solid.
Every time I hear solid today, I just keep on thinking of like the one scene from like Despicable too, with like the blind date lady.
Okay, where would I shade on this?
Below.
Below. So then our overlap is everything below the line and outside our circle. Do you guys think you can try a nonlinear one? Here's your problem to try. X squared minus 4, that's a parabola shifted down 4. So we could think about our transformations for that. Solid or dashed?
Dash.
Okay, so if you're trying to decide where to shade, you put in 0, 0. You get 0 is greater than -4, which is true. So we are shading inside this parabola. Second one, y is less than x minus 2. So line, y-intercept -2, slope is 1, so up 1 over 1. Solid or dashed? Hey, look at that straight line. Are you guys impressed? It should be. Less than means below. So our overlap is this little bottom of the parabola. Is that okay? Let's say I give you this problem. Oh, come on. So a system can include as many equations as we're given. It's not limited to just 2. So if I am looking at this one, what would we do to graph this first one?
Irregular line between 4 and 0.
It's, isn't it, between those two things.
Yeah, it's between these two. Okay, so if I said x equals -4, what would that be? A vertical line at -4. There's no equal to, so it's dash.
For some reason I couldn't figure out the word line.
And 0, so that would be a dashed line at 0. And we're shading in between the two. Okay, what would we do for the second one? So y is greater than -x plus 2. So y-intercept is 2, slope -1, down 1 over 1. Solid or dash? Dash. Okay, are we going to be above or below? Above. Greater than would be above. Alright, the last one is another line. Y is less than -2x plus 10, so y-intercept of 10. Slope is -2, so down 2 over 1. Solid or dash? Dashed. Okay, where are we shading? Above or below? So my overlap is this section right here. Sorry, it's going to be loud today.
That makes my head hurt so much.
Don't like all my shading?
This looks like a smart 2-year-old who knows how to graph and try and shake.
Well, sorry. Quit being judgmental.
I was trying to figure out who's drawing because my graph is not proportional.
Oh. Okay. Do we need more examples? Okay. So if you haven't finished last night's Math Excel, make sure you get that done. And then I have a handout for you for today.